I mentioned earlier about large networks can and should be divided into smaller networks called subnets, and sometimes you might just use the full term of subnetworks. Now, managing this can be difficult, but it can also be very beneficial. Now, without using any type of subnets in your network, you have only one network. And managing a network with so many different hosts is not practical unless you divide that network into those subnets. Now, to divide a network into subnets, you just designate part of the host portion of the IP address as a single subnet. Now, if you look at this example here, we have the first octet of this IP address, 69.0.0.0. 69 is the subnet of the network, and the last three octets are used for host addresses. And the number of hosts in which this network has is about 16 million. Now suppose you divide one network into 256 subnets by using the second octet for the subnet address. The last two octets are used for the host address in each subnet, with a potential of about 65,000 hosts in each of our subnets. Now the subnet mask used with IPv4 identifies each part of an IP address is the network portion and which part is the host portion. Using a subnet mask, a computer or other devices can know if an IP address of another computer is on its network or if it's on another network. If we look at this diagram here, you'll see the default subnet masks for classes of IP addresses. The green numbers here identify the network and the red numbers identify the different hosts. So you see we're using a class A here, and we have our subnet mask listed here, and once I said that the green identifies our network. You can see here in this address 89.100.13.78, 89 is our network ID, and the device has a host ID of 100.13.78. You see here with Class B, we use the first two octets for our network ID, and our Class 3 uses the first three octets as our network ID. Now we'll talk a little bit about public and private IP addresses. Now when a company applied for its networking license, it was assigned a group of IP addresses that were different from all other IP addresses and are available for use on the internet. Now, the IP addresses available to the internet are what's called the public IP address. Now we use that public IP address and we can conserve its public IP address because we only have a limited amount of those by using private IP addresses that are not allowed on the internet, so they're only allowed within our company network. So within the company network, computers communicate with one another using these private IP addresses, and a computer using a private IP address on a private network can still access the internet if a router or other device that stands between the network and the internet is using a NAT, or a network address translation. Now, network address translation is a protocol that substitutes the public IP address of the router for the private IP address of the computer or network device when the computers need to communicate on the internet. So our private IP addresses are kept inside, but we use that NAT if we want to talk out to the internet using one of our public IP addresses. So that's how it allows the communication for that. Now, because of network address translation, a small company can rely solely on private IP addresses for its internal network and use only the one public IP address assigned to it by the internet service provider for internet communication. Now, you might recall that the IEEE is a not-profit or non-profit organization which is responsible for many internet standards. Well, the IEEE recommends that we use the following IP addresses for our private networks: 10.0.0 through 10.255.255.255. For Class A, Class B, 192.168 116.0.0 through 172.31.255.255, and in our private network we also use 192.168.0.0 through 192.168.255.255. So when we have our own private networks, those are the ranges we should use for our private networks. Now from our networks, if a computer first connects to the network and it's unable to get an IP address or lease an IP address from our DHCP server, it's going to use what's called APIPA, or Automatic Private IP Address. And this is going to be in the range of 169.254.whatever to get a self-given IP address, or automatic private IP address. Now, as I said, we ran out of IPv4 addresses. We're now using IPv6 standards, and to improve routing capabilities. Now with IPv6, the address is changed to 128 bits that are written in 8 separate blocks using hexadecimal numbers, which are separated each by a colon. And here's an example I've given you here. Each of these blocks has 16 bits in each of these 8 blocks. Now there's some ways that we can rewrite our IPv6 addressing based on leading zeros or blocks that contain all zeros. So there's some rules to changing that. With the leading zeros in a 4-character hex block, you can eliminate that, such as this one here, right there, leading zero here, leading zeros here. But we also have these blocks that are all zeros. If we have those, we can eliminate those by placing a double colon. So you see down at the bottom here, we remove, if we have repeating blocks of 4 blocks of 0. You see we have 2 here, so we can replace those with double colons. So if you see a double colon, that says that there was a set, and only one set, of double zeros. And we can also remove any leading zeros in a block, as with here, we just remove the 0. So because there's not a repeat block of 4 zeros here, we have to include those in our rewritten address. But we remove the leading 0 from up here. We put a double colon for our 2 blocks of zeros, and then we remove our leading zeros in this block. We keep this block the same, and then we remove our zeros in the last block. So that is how we can rewrite our IPv6 addresses to make them more manageable. Now IPv6 classifies IP addresses differently from that which were used for IPv4. IPv6 supports 3 types of IP addresses. Unicast address, and when we use a unicast address, packets are going to be delivered to a single node on our network. If we're using a multicast address, packets are delivered to all the nodes on a network. And an anycast address is used by our routers. The address identifies multiple destinations, and packets are delivered to the closest of the destinations. Then we have 3 different types of unicast addresses, which are global, link local, and unique local addresses. And here's the information about those 3 types of unicast addresses.